Hello and welcome to part 5 of Speranza Guesses the Methods exam, the series where I guess the methods exam so you don't waste your holidays and you do some study instead. I've just got finished building the Razor Crest, so I'm going to put that over there and let's do some maths. So we're bouncing back to Tech Free again here. We've got a multiple choice question. Give yourself 90 seconds and then I'll come back and solve it. Alright, and 3, 2, 1, let's get started. There's lots of skills in here. It's going to be really fun to do. Let k equal this integral, then e to the k is equal to. So first we need to figure out what k is by solving this integral, and then sub k into e to the k to figure out what our answer is. Alright, so we've got k equals the integral -1, -2, 1 on x. Now you should know that the integral of 1 on x is ln x. And we're integrating that between -1 and -2. Alright, so our next step here is to sub in -1 and -2 for ln x. So we're going to get ln -1 minus ln -2. And this feels like a big problem here because you really don't want negatives inside of natural logs. But we're going to be able to overcome that because we've got a log law here where we can say that ln -1 minus ln -2 is the same as ln -1 over -2. And amazingly, magically, we now get ln 1/2. We've gotten rid of those negatives, which means it's not a problem anymore. Alright, so k equals ln 1/2. And then e to the k is equal to, so e to the ln 1/2. I've talked about this in a previous video. If you see e to the power of ln to the 1/2, that's simply going to be equal to 1/2. And you can watch that previous video if you want to see the thinking there. But if you've got e to the ln something, the answer is going to be something. I'm not going to explain why in this one. Alright, so our answer here is E. Again, in the Queensland paper, we're not going to have an option E, but there it is. Alright, next question. Shout out St. James Lutheran College. Mrs. Brogden sent this one in. That's the second one. Give it a try. Give yourself 90 seconds. And I'm going to solve it in 3, 2, 1. Let's do it. Alright, the position of an object is this, where x represents a position. We're going to find the acceleration. So we're going to have to derive twice to get from a position equation from a velocity equation down to an acceleration equation. So x equals 3t cubed plus 5t squared. Velocity equals 9t squared plus 10t. And acceleration equals 18t plus 10. Its acceleration at 2 seconds. Acceleration equals 18 times 2 plus 10. We get 36 plus 10. We get 46 meters per second squared. So 46, we got an option B here. A nice short, sharp one there, but you need to be able to move from position to velocity to acceleration and be able to sub, or if you know the acceleration, then find the time. Definitely going to be there somewhere, this question, definitely. Alright, so here's a question, tech free. It's worth 10 whole marks, so you should be able to spend like 15 minutes on it. It's probably more like 12 minutes or something that you should be spending on this. Give it a crack, and then I'll come back. Alright, I'm going to solve this in 3, 2, 1, let's go. Alright, part A, determine a simplified expression for the derivative of x ln x. Alright, so this is a product rule style derivative because we've got u and we've got v ln x and ln x. So u equals x, u dash equals 1. Be careful when you're deriving that. Some people decide that it's 0 or some other thing. U dash v is ln x and v dash is 1 on x, which means that the derivative with respect to x of x ln x is going to be equal to u v dash, so x times 1 on x plus 1 times ln x, which is obviously just ln x. So what do we end up with? X times 1 on x is just 1 plus ln x. All right, that's a nice, neat little result here. The derivative of that is 1 plus ln x. All right, so this is going to be our first taste of integration by recognition here. We've got this part A here where we said that the derivative with respect to x of x ln x would be equal to 1 plus ln x. Now, if we integrate both sides here, the integral of the derivative with respect to x of x ln x is equal to the integral of 1 plus ln x. Now, the integral of the derivative, these cancel each other out, and we end up with x ln x equals the integral of 1 plus ln x. I'll just make a small amendment here. Because I've integrated, I've introduced a constant, a plus c here. So we get x ln x plus c. Okay, now I've been a bit lazy here with respect to x, with respect to x. Okay, set up. Now the integral of 1 plus ln x with respect to x, that's going to be equal to the integral of 1 plus the integral of ln x, both with respect to x. Alright, and the integral of 1 is x, and we're left with this integral of ln x with respect to x. Take a look back at the question. We want to know what the integral of ln x is. So we want to isolate ln x. So if I subtract x from both sides, I'm achieving that. So the left-hand side here is x ln x minus x plus c equals the integral of ln x with respect to x. Alright, let's take a look and make sure that's fine. X ln x minus x plus c equals the integral of ln x with respect to x. Done. Alright, integration by recognition, if you see it in an exam, it's going to be obvious because they're going to be asking you to do a thing and they're going to be asking you to use your answer from the previous part, show that this thing is true or integrate this. So it should be relatively straightforward to at least spot that you're doing a proof by recognition. No, sorry, integration by recognition. Alright, so final part of the question here. The graphs of the function f of x equals 5 and g of x equals ln x are shown below. Determine the exact area, and be careful here, between the x-axis, the y-axis, and the functions f of x and g of x. Alright, so they want us to find the bit between the two functions, but also between the x-axis and the y-axis. So just this region right here. So the way that I'm going to go about that is to find that region in there. I'm going to find the area of that blue region there, and then I'm going to find the area of this rectangle and subtract those two areas, and I'll know what the green area is. So that's how I'm going to approach this. Okay, so to do that, I'm going to need to know what this intersection point is here. Where do the graphs of 5 and ln x intersect? So 5 equals ln x, that's where they're going to intersect, right? Because y equals 5 and y equals ln x. So if I make them equal to each other, I'll know where they intersect. X equals e to the 5, just moving from logarithmic form to exponential form. Alright, so I know where they meet. They meet at this point here, which is e to the, or they meet at this x coordinate here, which is e to the 5. Okay, I'm also going to need to find the area of this rectangle, right? Which means that I need to know this point here. Alright, so I'll sub that back. Actually, I already know it, right? Because I know 5. Alright, so that's 5. Alright, so that means that I know the area of the rectangle. Area of rectangle equals 5 times e to the 5, which is just 5e to the 5. Alright, area of the rectangle, done. Now I need to find this blue area here. Alright, that area there, given I won't be using different colours in the exam, I'm just going to label this area B, and I'm just going to say area B equals the integral Okay, now what do I need? I need the integral between this top value, e to the 5, and that value there. Damn, okay, I need the x-intercept of ln x. Alright, so that's when y is equal to 0. 0 equals ln x. Alright, e to the 0 equals x. E to the 0 is 1. Alright, x equals 1. Let's put that one right there. So I'm integrating between the e to the 5 and 1, the function ln x with respect to x. Now, luckily, I know that the integral of ln x is equal to x ln x minus x plus c. Okay, so I'm integrating that. X ln x minus x between e to the 5 and 1. Okay, and now I'm subbing in a bunch of stuff into that. Alright, so I've subbed it all in there. I just subbed e to the 5 in, minus subbing 1 in here. Some really interesting things happen when we do that. We've got e to the 5, we've got ln e to the 5. Alright, so we can bring that 5 out the front. 5e to the 5, ln e. Oh, wait a minute. Log base ee is 1. So 5e to the 5 times, this is 1 here. So we can get rid of that entirely. So we just get 5e to the 5, that's neat. Minus e to the 5 minus 1 times ln 1. Log 1, log base e1 is equal to 0. So all of that goes away. 1 times 0 is 0. Minus 1 is plus 1. So I have 5e to the 5 minus e to the 5 plus 1. That's my area of B. The area of my rectangle is 5e to the 5. And now I want to subtract one thing from the other. So total area is equal to the area of the rectangle, 5e to the 5, minus all of this stuff I just found. Equals 5e to the 5 minus 5e to the 5, that's gone. Minus e to the 5 is positive e to the 5. Minus plus 1 is minus 1. My total area is e to the 5 minus 1. And just for, let's say, units squared, because it's an area. Alright, this question. Whew. There's some stuff going on there. Really awesome log laws. There's integration by recognition. There's area between two curves. That's fun. Is it question 15? No, I don't think so. It's probably closer to question 17. I haven't solved that before. I made this video. You were watching me solve it. So you should notice that it wasn't a linear path, right? I didn't realize at the time that I already knew what 5 was. I didn't realize that I needed to know this x-intercept until I did. When you see a question that you've never encountered for the first time, don't be scared to just make a start, just do a thing, and then see what happens after that. Alright, determine the equation of the tangent to the graph f of x equals root 2 cos 3x at point pi on 4, f pi on 4. Alright, what's it worth? It's probably worth 4 marks. So you should probably spend about 6 minutes on it, I would suggest. Alright, have a crack. Alright, I'm going to solve it in 3, 2, 1, let's go. Okay, you should know how to find the equation of the tangent to a graph. This should be second nature to you. You should have practiced this a lot. I'm just going to talk about this graph for a second. F of x equals root 2 cos 3x. If you think back, you should be able to graph it. It's a cosine function, so it's going to start up here. It's got an amplitude of root 2, so it's going to go from root 2 to negative root 2. It's going to go something like that, right? And it's going to have a period of 2 pi on b, 2 pi on 3. So it's going to repeat every 2 pi on 3 times, which means that this is 2 pi on 3. And that means that this is pi on 3, which means that pi on 4 is slightly smaller than pi on 3. So it's probably about here somewhere. So I reckon the tangent that we're looking for looks something like that. So why did I bother to do that? Well, now I know that I know a couple of things. I know that this point here should have a negative y coordinate when I find it, or at least I think it should. I also know that my equation should have a negative gradient. If at any point while I'm working through this, I find that those things aren't true, then maybe I need to rethink what's happening. I can also see that well, I don't know, it's not drawn to scale, so maybe not, but at least I know that. All right, let's get started. So I definitely want to know what this point is. At the moment, I know that it's pi on 4 something, but I don't know what that is. I need to sub pi on 4 into my function. So f of pi on 4 equals root 2 cos 3 times pi on 4, which is, of course, 3 pi on 4. So cos 3 pi on 4, if you draw in your unit circle here, 3 pi on 4 is right here. And you can use your little cast thingy here. We know that cos 3 pi on 4 is going to be equal to negative cos pi on 4. And of course, using your standard triangles, you should know that cos pi on 4 is equal to 1 on root 2. So we get negative root 2 times 1 on root 2. And that's negative root 2 over root 2. Now that's really nice because anything divided by itself is equal to 1. There's a negative there, so our answer is negative 1. We now know that that point is pi on 4, negative 1. All right, what else do we need? We need to know the gradient at that particular point, which means we need a derivative. So f dash of x equals a root 2. The cos becomes a sine, a negative sine. We also need to bring the derivative out the front. It's a chain rule style question. So we're going to need root 2 times the 3. All right, so there's a lot going on here. It's negative. We multiply by the 3. We get a root 2 here and sine 3x. All right, I'm happy with that as the derivative. And now we need to sub in f dash pi on 4. That's going to be equal to negative 3 root 2 sine bracket 3 pi on 4. So I've just subbed pi on 4 into my equation here. All right, same sort of picture, but this time we are in the sine quadrant, which means that this is going to be equal to negative 3 root 2 sine pi on 4 this time. It's negative because it was originally negative, right? So the sign doesn't change. And sine pi on 4, again, using our standard triangle, is going to be 1 on root 2 again. So we have negative 3 root 2 times 1 on root 2. That's going to be equal to, the root 2 and the root 2 cancel each other out. We get negative 3. All right, we're nearly there. We need the equation of a tangent. An equation of a tangent is going to be equal to y equals mx plus c. And we know a y coordinate is negative 1. We know the gradient is negative 3. And we know that x at that point is equal to pi on 4. Okay, which means that our c value is going to be equal to negative 1 plus 3 pi on 4. That's equal to c. We're really finished here now. Therefore, the equation of the tangent is equal to y equals the gradient, which we know is negative 3 x, and the c value is negative 1 plus 3 pi on 4. It's not an equation of a tangent that you normally see, but I have seen equations of tangents appear with this kind of thing before in QCAA materials, so I wouldn't be surprised. Now, it's worth considering my picture to see if I think I'm correct. And if we go through it in turn, we've got this negative 3 here. We expected a negative gradient, right? Okay, that's good. And then, oops. And then this other bit here, negative 1 plus 3.4, that represents our y-intercept. Now, negative 1 plus 3 times 3, that's 9, 9 over 4. 9 over 4 is a little more than 2, right? So negative 1 plus a little more than 2, that's going to be a little more than positive 1. And you can see the drawing that I've drawn here. Yeah, it's at the moment it's going through root 2, which is about 1.4 something, I think, which is about right. So everything that I've done in my picture, everything that I've done in my working seems to suggest that this is probably close to the mark. All right, that's 4 questions down. We can tick them off here. We did 2 tech-free ones. We did 2 tech-free multiple choice, 2 tech-free short response, which, as you can see, means we are halfway through the paper. All right, that brings us to Friday. I've done 5 of these videos now, 20 questions done. I'm going to take a break for a couple of days. I'm going to make another video and upload it on Monday. I hope that you're continuing to work through this stuff. You've got 20 of these questions. You should have spotted something that you just didn't know, something that you need to work on. Make sure you're doing that. You might want to write it in the comments or something. It'd be nice to know that people are watching these videos. So give me a shout out if you are watching these videos. Good luck. Keep studying.